This is Ray's magnetic cannon 4 called the Surf Rider. And the setup I have here is I have some 3 magnets there. They're discs. They're 2" by 1/8 inch. I have an arm. On the end I have a magnet that can swivel nice and free. I'll explain the function. If you've watched Ray's magnetic cannon 1 and especially 1 and 3, you'll see what it does. So first of all, I'm going to point out the riding the wave. Okay. I'll go ahead and we'll demonstrate, but you'll see the magnet as it approaches the stator magnet. It'll bump up and ride that magnetic wave. So it's a low power, so the only thing that's really being exerted is lifting the weight of the magnet as it rides the wave. The second half of the cycle, I call it the wipeout. If you've ever seen a surfer, they're riding a wave, and if they wipe out, they fall into the power of the wave, and that's where the danger exists. It may be he is pulled under and thrown against a rock or the bottom. So the second half, it goes into and through and drops through into the wave, and it accesses the power, and it's a high power at that point. And we'll go ahead and do some measurements also. So I'll be back in just a little bit. Okay, the first part again is the riding the wave. And you'll see the action of the rotor. See how it lifts up and rides that wave. These are south, up. They could all be north also. This is south coming into the rotor. This is south. They could all be north, north. So south and south repel. So that rides up over like poles repel. And it comes down through into the wave. We'll measure both those forces. Okay. We'll set up for measurement. I have a meter that's sensitive to 0.1 ounce. So first of all, we'll go ahead and measure the forces it needs to be pulled through. This would be considered my input. The focus of my experiment is that if I can have less power to pull my rotor through as to the power I get output as it hits the truck or the car, then I would consider that a gain or an over unity result, according to me. Okay? I have it set on the ounce scale. It's sensitive to 0.1. There is a force there, but it's less than 0.1 ounce. You can see it riding the wave and fire through. Okay. Second. just when it breaks away. So there's a I'll reset the camera so you can see the last one. .6. We'll go slow enough. That's just that breakaway. Has a small lockup point right there. I would say that goes negative because of the spring in there. Flaps a different direction. But except for those two little points where it sticks, I'd say 99% of the cycle is less than 0.1 ounce. Okay, so now we'll go ahead and measure the output, which is what propelled the little car. We'll set up for that. Okay, now we'll take the measurement of the output. That's the force that hit the car. So I'm on the ounce scale again, sensitive to 0.1 ounce. About 8 at the high point. So we have that brief 0.6 ounce, but 99% of the input cycle was less than 0.1 ounce. Our output was 8 ounces. That's about an 80-fold increase between, I'm just considering the forces itself. You'd have to work out the distances and so forth. But just force-wise, we have an 80-to-1 ratio. Coming back takes a lot more power. So this is actually set up for a rotary device. It could keep going and going. Numbers 1 and 2 raised cannon, it was set up where it was really hard to have the continuation of the firing. So I worked at this a while to get a rotary firing. So we'll come back and show you what else we can do with this. Okay, I have one of these little piezoelectric speakers, and they provide a small voltage as you strike it. I have 3 LEDs back there. So we'll fire it. I don't have it really accurate to hit that right, but we'll do what we can, huh? But anyhow, this shows you that it has enough power to provide 3 LEDs to light up. Not a lot, that doesn't take much for an LED, but it kind of shows you. This is actually hitting at the bottom. It should be hitting at the center, and it would be a lot brighter, but that's what we got. Okay, so anyhow, we are providing a more power out than in. Now, there may be some places there I'm not really realizing, but from what my point of view and my testing is, that this is the way it works. It has a riding feature. You can see even on the back swing, but a little bit more power to reset it. So that's why it goes in a circle. See how it rides up over the wave. So you don't have a lot of power. It's just the weight of the, and there is some. It feels like a magnetic pull also, but it's not enough to set off the 0.1 ounce, except briefly there. Okay, so I'm going to set up a few different types of magnets to show you don't have to have these 1/8 by 2. The gap here, I have a small, this is off of a blade of a big hacksaw blade, but it brings down this magnetic face. This is a south face, so it helps kind of purify it. You're trying to get away from all the interactions of the north-south, because that's what really locks you up. So I'm trying to get out of that interplay and bring it out a little bit. And also looks like maybe, from the magnet down, this is a 1/4 by 3/4 by 3/4, 1/4, 3/4 by 3/4. And that magnet itself looks to be about 1 inch, 1.25 inches. This blade here looks to be about 1/2 inch or so. But you can adjust that. You can see where I drill holes and things like that. So I'll get my other magnets and I'll show you how that is, and we'll finish off. Okay, I put ceramic magnets down there with the south pointing out. These are 1/2, 1/4 inch thick, 1/2 by 2 inch. Okay. A fire going through there. They provide enough power to boost it through there. So anyhow, you can use anything with a north face going up, and the principle is pretty straightforward. You ride the wave, the magnetic wave, and then you go down through the wave, you catch it. And it takes less power to ride the wave as it does to come back, and as it comes with the wave, it catches the power of the wave, and that's where the OU comes from. So I'll set her back up for the Neos, and that'll be the finish. Okay, I'll finish by firing a few times. So there again, to summarize, it's a rotary setup, and this works a lot better. The other cannons I had, they went along a guide bar and there was friction there and so forth. This is working on a different principle. I like it real well. Seems to be a more simple construction. And there is a small force there again, so it's not that it's zero, but it's very small compared to the output. So that's what I consider OU, or over unity results. There's more power in the output swing than there is the loading cycle. So this is a pretty easy setup to do. So thanks for watching. Hope you enjoyed this series. It's a lot of fun. This may be the last of the series. I have some other ideas I want to follow up with. Thank you again.